Hello, I am ready to review with you how to work through the problems for your second learning goal for the thermochemistry unit test. The second learning goal was that you can solve thermochemical equation problems. In other words, you can solve for the energy involved in a chemical reaction or use energy to solve a problem. What we're really doing here is stoichiometry, and you guys are awesome at stoichiometry, so this should be a piece of cake. I have a couple of example problems that are not on the review. I didn't want to use any of the review problems because I want you to get as much practice as you can. So you can just follow along while I do these problems and then go back, and hopefully it will give you enough information to be able to figure out the ones that you have in front of you. And of course, you can check your answers on the answer page, and then I can help you too as needed. Okay, so let's switch over here to my document camera and check out our first example. First thing I want you to remind you of when it comes to thermochemical equations is that we, of course, know from doing stoichiometry that the coefficients, although this reaction doesn't have any coefficients, but here are the coefficients, in front of the atoms and molecules represent the number of moles that are involved in the chemical reaction, and that's still true with the energy, but now we can add energy in as part of that like equivalent statement. So this would essentially say that 1 mole of magnesium hydroxide is equal to 1 mole of magnesium oxide, which is equal to 1 mole of water, which is equal to 37.1 kilojoules. And then we can make that into a fraction and change our units and all the stuff that we're really good at. Okay, so let's check out this first problem. How many grams of magnesium oxide? So that's what I'm looking for, is grams of magnesium oxide. And you, of course, want to, or well, I guess you don't, of course, want to, but I love to label my equations because I think that helps me stay organized. So I'm going to put a question mark in gram there so I know that's what I'm looking for. So how many grams of magnesium oxide will be produced if 1,000 kilojoules of energy is absorbed by the reaction? Okay, so remember, I have to have a number to start, and we used to say that you had to have grams or liters. Well, now you can also have kilojoules. So I have 1,000 kilojoules of energy to start. So that's where I'm going to start. So I'm starting with 1,000 kilojoules, and the problem is asking me to go to grams of magnesium oxide. Can I convert straight from energy to grams? The answer to that is hopefully no, right? What unit do you have to be in to change identities or to convert between two substances? The mole. Very good. So the first thing I want to do is convert energy to moles, okay? So I'm going to set up my little conversion fraction here, and I see that there are 37.1 kilojoules of energy for every 1 mole of magnesium oxide. Remember, no number in the front means 1. So I'm going to put the 37.1 kilojoules on the bottom so that the words will cancel, and the 1 mole of magnesium oxide on the top. And then I will just solve that real quick. So 1,000 times 1 divided by 37.1 gets me 26.95 moles of magnesium oxide. So I have successfully converted or switched between identities, but I'm not quite done answering the question because it did ask for grams. So in order to convert from moles to grams, you of course know that you have to know the molar mass, right? So you can look up the molar mass of magnesium oxide and see that it is 40.34 grams, right? So I can either just like straight look it up since you have your computer now, or I can add 1 magnesium and 1 oxygen together, okay? And then I just have to solve it. And again, we wrote it this way so that the moles would cancel, right? And again, the way I will solve it is I will take 26.95 times 40.34. So I get 1,087.16 grams. Okay. So again, just to review, I took my given energy, I converted, or I switched identities. So I went from energy to moles, and I got that ratio from the balanced equation. And then once I knew how many moles I had, I could convert that out to whatever unit I needed. Okay. Let's check out number 2. So in number 2, it says that I have 200 grams of magnesium oxide. So 200 grams of this, okay? And I want to know how much energy will be released. So I'm ultimately looking for my kilojoules here, okay? So I'm going to start with my 200 grams. Again, I have to have a number in either grams, liters, or energy. and I want to switch from one substance to another, I have to be in the mole to do that. So I'm going to use the molar mass of magnesium oxide, which I looked up for the previous problem, so that makes this one easy. I keep wanting to say that it's 24. That's because magnesium is 24. It's 40.34 grams. Okay. So we're going to do 200 times 1 divided by 40.34, and it gets us 4.96 moles of magnesium oxide. Okay. But that doesn't solve the problem because I want to go to energy. So the next thing I have to do is look at how my moles of magnesium oxide are related to the energy. And I see that there are 2 moles of magnesium oxide for every 1203.6 kilojoules of energy. So I can take that equivalent statement and write it here as a fraction so that I can change up units. So I'm going to put the 2 moles of magnesium oxide. And I really want you to make sure you understand where that 2 came from, right? Do you see that? It's from the balanced equation. Okay. Same thing happened in the first problem, except it was just a 1. Okay. And then, of course, I put my 1203.6 kilojoules. Now, some people get really concerned about the fact that that's a negative number. It doesn't matter because that negative is just telling me the direction that the energy is being produced or lost. So you can leave it, you can drop it, I don't care, right? Whatever. It's just telling me the direction, okay? So we're going to do 4.96 times 1203.6 divided by 2, and we will get 2,984.83 kilojoules. And that is my answer. Okay, see, those are easy. You guys are great at stoichiometry, and that's all that is stoichiometry. I do want to check out B. I'm not going to solve this last problem, but I just want to talk about it for a second. So notice in this problem, sorry, we need to see the reaction still, that I have 50 grams of magnesium and 50 liters of oxygen. So notice that I have information about both reactants. What kind of problem does that mean I'm going to try to solve then? So I've got 50 grams of magnesium, 50 liters of oxygen, and I want to know how much energy will be produced. Anytime you're given information about all of the ingredients, that is a limiting reactant problem. So let's just review really quick. What do you have to do to solve a limiting reactant problem? Okay. First thing you need to keep in mind is that you're going to have one problem for every, or for each reactant. Okay, one problem for each reactant. Hold on one second. Troy, I'm recording a video. Okay. One problem for each reactant, and you need to, this is really important, you need to solve for the same product. Okay, so the number one mistake I see people make on these problems is that they solve for one problem for one product and then another problem for another product and then try to answer the question. It doesn't work. You have to solve for the same product. In the case of this particular problem, you're solving for energy. Now, you'll get 2 answers, right? But there's only one that's possible. It's the smaller one is correct. So you will absolutely have one limiting reactant problem on your test, okay? And so when you have that problem, make sure that you put down the smaller answer for your final answer. That's one that you're going to type into the box, okay? Don't do anything crazy and like add them together. Don't do that, all right? So again, you've got 4 problems on your review to practice, not to mention all the ones that you have on your worksheet when we originally did this back before spring break. So do those 4 problems, check your answers, and then if you didn't get them correct, see if you can figure it out. And if you can't, please reach out to me ASAP. This part takes forever.